Okay, well, I've made a few changes since last time. Um, the major change here is to do the grid computation in the background task. I looked at the Unity job system and it seemed like a lot of work, and it seemed like the job system was really aimed at um, kind of high frequency jobs, whereas really what I wanted to do is just do tasks in the background and be able to pass around objects and have normal garbage collection and so forth. So I went with just C# tasks. So I'll show that in a minute. I also imported a couple of packages. These are packages that I got out of a bundle that I bought a while ago, a Humble bundle. So this had a whole bunch of effects. Oh, I have to drag this higher for you to be able to see that. So basically, well, I imported the standard Unity effects, but then I think I imported, well, universal sound effects. So I got some sounds out of that, and I also imported effects examples. I think that this was just a standard Unity set of effects, not a I don't think this came with a Humble bundle. I think this one's free. So let's have a look and see what it looks like now, and then I'll walk through some of the code. Some of it I'm still kind of reorganizing a little bit. So you can see I added sound and an explosion animation. Which is a particle effect, that I got out of the which I got out of that pack. I still have the firing sound even when you're building, which is perhaps a bit silly. It is now actually quite fun, just going around and blowing up stuff. Build, of course. So notice there's a limit to it only does one digging operation at one time. It only does one digging operation at one time, so we can see that in a moment. See if we can go through this tunnel that we made. Not quite. I can come out the other side. So there's a bit of a tunnel through here. Okay, so it's quite fun actually. Just adding in that sound effect and animation makes it more satisfying, destroying the terrain. But let's have a look at the code. It was earlier today that I generated the task model, so I'm just looking for where that is. So now this is the voxel surface object. So this is one of the squares, and it has a generate mesh function, and this returns a task. And why I'm returning the task we'll come to in a moment when we look at the grid array. But so this doesn't let you have more than one task in progress at one time. And I actually have this structure kind of duplicated now at 2 levels. So I think this one at this level is probably a little bit unnecessary. Anyway, if there's no task in progress, then it will create a new task. This is using the C# task system. The thing with Unity is also a thing with a lot of OpenGL libraries, is that you can only update OpenGL entities when you're on the main thread. You can't do it when you're on other threads. And so this background task is going to compute basically a new mesh, but it's not going to apply that new mesh in the background task. It's going to wait and apply that later. So this creates a new task, and the task takes a lambda here. And inside I create a new instance of the update mesh job class. It's the name of this is still an overhang from I started off trying to use jobs but then moved to tasks. And so it takes the entity field and it clones it. The reason for cloning it is I just want it not to be updated while the task is computing. And then it also passes in the size and material scale. These are needed in order to compute the new mesh. And this job object has an execute method on it. I call that, and then return the update mesh job, which contains the computed result in it. Okay, so after creating the task, I start it, and then the task is returned. So we can have a brief look inside this guy. This is just all of the code that I had before that does the dual contouring. I moved it into this class. It's perhaps a little bit ugly that it's all in this class in this current way. But this execute method just is essentially computing a new mesh, and the result is left inside this mesh builder class that I had from before. Let's go back. And look at who calls this. So this is called from grid array generate. Generate is just a button in the UI, and all it does is on every surface object it calls generate and then adds the task to a task queue. So now I had the challenge that I wanted these background tasks to run when they're in the editor and also when the game's playing. So I'll jump back actually to Voxel service and have a look at that. So we have a method called update mesh, and update mesh just does a lock. I guess it's kind of unnecessary since you're on the sort of UI thread in order to call update mesh. So this lock's kind of unnecessary. But what this does is it says, do I have an update mesh task that has completed? And I guess that's linked up to this guy here. If I do, then I will basically copy I'll copy the mesh out of there into the OpenGL mesh, and then set the mesh task to null, which will allow this guy to, if generate mesh is called again, then it will do a mesh recomputation. The structure, I guess I'm not that happy with the structure because it's a little bit racy. So like if you call generate mesh, then, and it's already generating a mesh, it'll just ignore that request to generate a mesh. It would be better if it kind of queued up a desire to generate a mesh and then just kept generating meshes until there were no more requests for it to generate a mesh. Anyway, most of the guarding is happening in grid array, so let's have a look at that. So grid array also has update mesh, and it basically waits for all outstanding tasks to complete, and this is why on the voxel surface, it returns a task, and then the grid array is basically collecting all of the update tasks that were executed and waiting for them all to complete before it tells the surfaces to actually update their mesh. And the reason for that is that if you just let the tasks complete and then update the meshes after they're finished, they can complete at different times, and then you get tearing between different grids in the cell, different cells in the grid. And so to avoid tearing, I let all of the updates complete before I apply any of those mesh updates. And this seems to work reasonably well. And then the next thing that perhaps is interesting is how to do those explosions. So here the structure, I was just playing around with the structure. It's not necessarily a particularly good structure. I have the code actually in two places. So there's a dig controller. So this is what's responding to a click. So we looked at the events manager in the last video, and the dig controller is going to make sure that the mouse is disabled and that the system's not currently digging, and that means that it's ready to sort of detect a hit. And then I have this component called the dig head. This item just gets moved to wherever the current center of the screen is pointing at. I ended up not using this. So when I first had I started off having a particle effect at the position where the ray was hitting the surface, but that didn't look very good. So I removed that in the end. But anyway, that's what this dig head object is tracking. It just gets moved around to wherever the point that's currently hitting. So these lines really don't do very much. They just end up storing a variable that gets used down here. So then if you left click, the first thing I do is I instantiate the explosion prototype. So I got this explosion out of the effects package. It's a particle system. And the reason for instantiating the prototype is that way, what I was doing originally is that I had this object and I was just moving it around. But you really want the explosion to be where the center of the digging is going to take place. And so instantiating it leaves an explosion there. It lets you have two explosions at once. I should also show you the explosion. I had a bit of trouble originally. Let's drag this up so you can see. So this plasma explosion effect, it had looping turned on originally. So I had to turn looping off so that way it would only play once. And the other thing that I did to it is I said the stop action is to destroy itself. So that way it plays through once and then it destroys itself. So that's instantiating the explosion. And then I added an audio source to the dig head. And then I tell that to play one shot of, I have an audio clip here called the dig clip. So I set if we look at the dig head, I set that has an audio source on it, and I think it's on the dig controller that I put the explosion prototype and the dig clip here on the dig controller. So that's the progress I've made. Most of the work was rearranging the code so that it would go into the task model, and then playing around with these two new systems, playing around with sound and also playing around with an explosion prototype. So before I sign off, we can play again and we can dig some more holes. It's actually quite a lot of fun. It is actually quite a lot of fun. I can't resist firing and talking at the same time, which of course doesn't work for anyone listening. Well, that's it for now.